Now that we have an overview of the steps of the scientific method and why it's such an important tool for discovering the world around us, we're going to kind of start at the very beginning with the scientific study and just walk through all of those steps. Really, the beginning of the scientific study is an observation. So we observe the natural world around us, and when we see certain observations, it kind of causes us to question how that is working the way that it is. So for example, kind of personally, I have a farm, my husband and I do, and on that we mainly have chickens that are egg laying. And this is a pretty decent side business for us. I mean, for reference, we have like about 1,200 chickens right now, so it's definitely a little more than just a hobby. And we're always trying to maximize our outcome with eggs, because the more eggs the chickens produce, obviously the greater the profit margin. So maybe I noticed that the chickens, and this is a true observation, they seem to lay more eggs in the spring than they do in the winter. And I might really want to know why that is, because if I can pinpoint the why, then maybe I can change something to maximize egg production. Well, with that observation comes the natural tendency to try and explain the observation. And so these possible explanations have a name within the scientific method. It's called a hypothesis. So a hypothesis is a proposed explanation to the observation that was made. We always expect that an observation is going to generate a multitude of possible explanations for us to investigate. And that's really what the purpose of the scientific study is. It's to evaluate one hypothesis at a time and determine if it's a valid explanation or not. So let's get an example, and then we'll kind of talk maybe about a little bit of criteria of what a scientific hypothesis can and cannot be. On the previous slide, I said that I had observed that my chickens lay more eggs in the spring than the winter. So I might naturally start to think to myself, what is different about these two times of year? An example would be obviously temperature. So maybe my hypothesis would be something along the lines of the chickens lay more eggs in the spring because it's warmer. Now, we know for sure that this is not the only possible thing that differs between spring and winter, right? There are lots of things that are variable. So maybe another example would be, I'm not going to rewrite this beginning piece, but maybe another example would be because it is more humid. So maybe humidity changes it. Maybe it's because of the amount of daylight, right? There's lots of different possible explanations that we could put here. Kind of one thing that's true is that we have sort of a template in which our hypothesis can fall into. Kind of what I'm doing here is I am restating the observation. I am inserting the word because, and then I am putting in sort of that proposed explanation that I would ultimately want to test. Hypotheses don't absolutely have to follow this format, but that is a good format to start with as you're kind of getting your feet wet with proposing hypotheses. Now, a hypothesis can't just be any possible explanation for it to be a scientific hypothesis. A couple of things have to be true. First is that the explanation needs to lead to testable predictions. So the variable in question needs to be something that we can manipulate and see its outcome. So for instance, can I have my chickens in an environment where the temperature is changed? Sure, you can temperature regulate buildings. We do it all the time with air conditioning and heating, right? So that's testable. Can I change the humidity? Well, sure I can, right? I can add a humidifier, a dehumidifier. So we have to have an explanation where we can actually test possible predictions, okay, that come from it. So is my variable testable? And then also, is it falsifiable? And that usually kind of goes in hand with testable. I have to be able to show that it is false in order for it to be a scientific hypothesis. So this means that science is not going to be able to evaluate every possible explanation that you could dream up of, right? There's going to be some things that are not physically testable or measurable, and we couldn't evaluate those with the scientific method. So for instance, anything kind of pertaining to the supernatural or morality. So, I've got a picture of a ghost here to kind of remind me of supernatural. We can't actually measure paranormal activity. Things regarding like morality would be also things that we can't tackle. Or, what is beautiful, such as this painting over here on the left. Those are really good questions, good observations about the world around us, but we can't ultimately answer those with the scientific method because they encompass factors that we cannot manipulate and test. Okay, so we have to have an explanation that is testable and is falsifiable, and there are going to be a lot of valid questions in the world that science can't tackle, and rather other disciplines are kind of tasked with those. So for instance, if we're thinking of morality, that would be philosophy would likely want to tackle that, and or religion. Okay, so the hypothesis needs to lead to a testable prediction. Well, what is a prediction? A lot of people use hypothesis and prediction interchangeably, but they are not the same. A prediction is the outcome Okay, so the prediction is an expected outcome. It's the outcome that you're going to expect in the experiment that you're going to run where the variable you hypothesized about is changed. So for instance, if we go back to my previous example where I thought maybe temperature might explain differences in egg production, then I could say something along the lines of, if I place some chickens in a, let's see, what's the temperature typically around the spring? 85 Fahrenheit coop. Then they will lay more eggs compared to those in a 40 Fahrenheit coop, right? So now I'm starting to predict what outcome I expect to see based on the explanation that was proposed. And so the idea is going to be that I'll run the experiment and see if the prediction is backed by the data or not. And then that will kind of help me decide if the hypothesis is valid or not. So if we're thinking about how these are different, right? The hypothesis is the explanation. And specifically, this is the explanation that is being tested. The prediction is the outcome we expect based on the hypothesis. So the hypothesis comes first, and from that, what we do is we can predict outcomes based on our hypothesis within the experiments that we design. And that's going to help ultimately help us determine if the hypothesis is valid or not.